Recording. Yes. I don't hear you. I see it. Yeah. Good. That's it. Yeah. Let's go. Thermometers is the origin for those in the northern hemisphere. So if you're working up here, right, Africa is something like that. Roughly, are you okay? So Ghana is somewhere there, right? So we are in the northern hemisphere. Yes. Like we like Ghana. So obviously, the northern, so the false northern is thermometers and then 10 million. 10 million meters for those in the southern hemisphere. Okay. Hemisphere, northern hemisphere. Okay. Right. Then we have the false easting. So for the false easting, we have to divide the whole globe into zones. So this is one for X. We divide it into 60 zones. Okay? So if you divide the whole Earth into 60 zones, every zone will be the width. Every zone. Divide the whole globe into 60 zones. What will be the width of every zone? So calculate it. You don't look and get the answer. You have to calculate. Say again. Huh? Oh no. No. So all of you calculate it. Don't stay. Do it. Take a pen and do it. Calculate it. Yes, what's the answer? How are you doing it? Before you do anything, ask yourself why. The reason. There should be a reason for what you actually, whatever you're doing. Now, how do you do it? How do you divide the Earth into strips? How do you do that? How do you do that? Those online, I'll show you the globe. I'm waiting for your answer. It's so easy that I'm surprised you're not getting the answer. That's why I've gone quiet. Yeah? On the surface or inside? On the surface. Exactly. So how do you do it? Yeah, but what the value? What will be there? How big will it be? How large will the width of the zones be? No, really. Not really. Because degrees, you see, what you can measure distance in degrees. Are you aware? So all these quantities we are talking about, you know they are in degrees. So if you have 0 degrees for the Jewish hurricane, you go around and come back, you've done 360 degrees. Are you getting now? All right, great. So that's it. We can have the advanced 60 zones, okay? Now the central meridian for every zone, right? Will not be the first system of 500,000 meters. So the origin for a particular zone is the intersection of that would be the origin. In the same page, it's a concept. Exactly. You are not even calculating anything. You don't have to calculate anything. Yes, absolutely. The first is this one should come. But my question is not sure, but you know, I don't want you to feel. So let me be one. Example. Don't chew and what? It won't work. It's all right. My questions are like that. If our AIT will make sure that your questions are not like, are you out? There's a way we set questions. They will tell you this question is too easy. So now you can't even blame a lecturer anymore. It's all, yes, it's the standard. IOP is a world standard university. And I can't international university. Are you right? You have to do a test according to the. So that is basically with 60 zones. Every single one of this is what? 6 degrees. 6 times 60 is what? 360. And that's the UTM. Yeah, that's it. Let's go our scale factor. Distortion. That's the last one of universal triangles in the equator. We are describing the result of distortion. So the central meridian has distortion of 0.916. Extreme ends, we have 1.00. 1.00. That's the scale for IOP, literally that's a distortion. All right, let me tell you how this makes sense. To bring it down. If you, okay, you were reduced in size, right, by a factor of 1, how would you look like? Yes. To get it. So that's why these values are close to 1. The extra thing you see in there, so if you add 0.004 to the square, so close to it. This is a so close to it. When we look at it, this is 0.9996. Between 1.000 and 0.196, you can see we are approaching 1. Right? So, to know how much an object is distorted, you simply multiply the distance by the factor, and you get to it. So if you have changed by a factor of 2, then it means what? It become double. There was a movie, it's a long time ago. Honey, I Blew the Kid. Who has said it? It's an old, very. Honey, I Blew the Kid. So in that movie, the daddy was actually some scientist. He was working on something, okay, genetic something. Then he was using some kind of rabbits to do the experiment. So it worked to some extent. He realized that the rabbit had to relax and become bigger, but well, they killed the rabbit something like that. But normally when he goes to the lab, he goes with his own son, his own child. And one day the child went into the machine, then he was exposed to the very thing that he was working on. The child began to grow up quicker than supposed to. Okay, so now he has to bring the child home. But as he was coming, the child was just getting bigger and bigger. Okay. So when he got home, then he has to hide a kid because the wife is there. All right. I'm talking about enlargements. Still fast. So honey, I blew the kid. Now he hit the child in one of the rooms, but the wife heard that there was some commotion going on, but the kid was now becoming bigger and he's beating the daddy up. Again, he's now getting bigger than the room itself. You get it? So now he has to hide the kid. He locked the door, and then the wife was, honey, what's going on there? So finally, he has to come out and declare what has happened. Say, honey, I blew the kid. He's blown the kid up. Now, if you don't find this funny, it means you're not going to be able to answer my questions in exams. And you didn't find it funny. It means we're not understanding what I say. That's how my questions are. Is that okay? All right. You didn't hear what I said. Yeah. Can you repeat the story? I'm going to put you on the spot. Can you repeat it? Why not? Hey. Yeah, fish. Those I won't let you do it. You know. All right. Okay. Guys, this is it. My projection. This is all I want you to do. Is that okay? This is all I want you to do. Time is fast spent. So this is what I'm going to do. I'm going to talk about networks. Not time is not fast spent. We still have like an hour. That was it. But instead of us to close, I'm going to start a new topic. Is that all right? So that we don't waste time. The idea is for us to do a practical. Is it possible for us to do a practical on laptops? We can do it. We can, or is there a lab with everything there? We can do it, isn't it? But this one is practical. Then you talk to you and you say, okay, I'm learning GIS. We say, what did you do? The software is. So all these things. So let's talk about network analysis. Is that fine? Okay. Because I think I do pass on to then we close. We close on this one. Is that okay? Network analysis. What's a network? What's a network? What's a network? You can give examples of networks. Really network. That's good. Another one. A chain of linkage. So you are trying to actually define what a network is. Okay, so you hold on for a moment. Hold on for a moment. Pipe network. All right. Good network, isn't it? Okay, so class rep, your name again. Your name again. Miguel. So you're trying to define what a network is. So what's common between all the examples we've given? What's common between the examples we've given? What's common between them? You said a chain of what? Huh? Connected points or something. Okay, like it's something like that. Really. You have links and you have nodes. The nodes represent the point at which there's the exchange or diversion. Like a pipe network, you need to get to a particular point where the meter is, the pipe continues. Then now it's diverted to your house. There you go, water. Okay. Is it? Yes. Intersection points, like for road networks, junction. You know, for road networks, we like call it. Is it Malam Junction, right? Malam Junction. The junctions are so important, so we always give it names. Okay, South Junction, these are points. They give even a name to the junction. Have you realized that? Once they have South Junction, it's like as if it's a town, but it's all because of the meeting of a road and another one, right? Do we all remember the concept of topology? The particular rule on connectivity. Do you remember that we said that arcs should meet at nodes? Okay, the beginning and end of an arc is called a node. Is that okay? All right, and then the points that define the shape of the arc is the vertices. Is that okay? Remember that? Great. So where we have two arcs meeting, that's like the junction. That's when we connect them like that, then we are forming a network. So I want all of you to be aware that that topic, topology, connectivity, has a direct link with what? Networks. And without good topology, you cannot have good network analysis because there will be bad representation of your network, the real network. Are we clear? Why do you think this is wrong? The question that comes in the exam is that why do you need to do topology? So why do we have to enforce that connectivity rule? Okay, why do you need to? Yeah. that sounds like, you know, home sense, you know, anything like wisdom from a grandmother. You understand? No, but that's the truth, and that's how you should answer some of the questions in exams. You need that, you know, wisdom from a grandmother. You get what I'm saying? So all the questions that in exams are that difficult. Some of them just this is what you must be talking about. Without connections, you can't have. You get it? So we talk about LinkedIn. There are connections, right? So we need to be connected, and the connections are coming from topology, the concept of topology. All right. One particular rule in topology is the connectivity. All right. Right. Why? What does it mean? It means every network is really made up of links or segments and then nodes. Are you okay? And then so these are being connected. All right. And then the resource can be shared. Are you on the same page? Right. So the benefit of having a network is that we can share a resource. All right. So as you said, the drainage network in Accra is one of the best in the world. Is that not so? That's why the gutters are stinking like that. Is that not so? Right? It's flowing, isn't it? It's this gas. I went to buy. I had to buy bread and egg. Okay. I just wanted to have some chocolate, hot chocolate drink, and then bread. So I went to a part of Kaswa. That's where I was spending the night. Honestly, I had to tell myself be strong. Because where I was standing, seriously, I began to ask myself, am I really an African? Like, do I really belong here? I don't think I belong here. Are you okay? Because I just asked myself, why? That's all that went through. Why? Because we don't have good words, drainage. So there's no flow. The flow, what is it? What is moving through a drainage network? Yes, when it rains, but apart from that, okay, that's when it even gets, you know, we get the water in it. So if it doesn't go, then it becomes what? Stagnant. And once it becomes stagnant, then what happens? It starts sinking, then we have mosquitoes breathing in it, and all the problems that we have. Is that also? Let's move on and talk about power network, utility, power network. So let's talk about, we can talk about, I'm going to call it electrical network, like power distribution. Power distribution. So now let's talk about water distribution. So do we have pipes here? The pipes here, pipe networks. We have it. You know, you're aware. Okay. Kaswa, we have it. But then we are not doing bad. Water is flowing everywhere. Are you in the same country that I am? Because where we are in Kumasi, there's no pipe there. We've been living there for years. What's the issue? It can't. So why don't you just give us the pipes? At least when the water comes. No, are you talking about the wells that we dug? Okay, okay, you are right. You are right to say that. But at least if we have the network, then we can think about distribution. Are we on the same page? All right. But the benefit of the network is to distribute. But it's like now we are just saying that it's the end of the world for you. Are you agree? There's no plan. Do you understand that? Okay, so we see the power of a network. Are you okay? Is it good to do an analysis on the network? It's very important, isn't it? Okay, for a road network, what are some of the analysis we can do? We can do an analysis and say that, okay, for security reasons, the president is moving to Kumasi. It's okay. But we don't want him to move in a certain direction. Are you okay? Tell us which direction we should pass. We need to go and call some experienced old man somewhere who now comes and say, all of you should pass through this place. I'm telling you, you should pass the gulf. We pray that he lives long enough to keep that knowledge. And if, because seriously, sometimes when we even talk about the road network in Ghana and they are mentioning the routes, I'm asking myself, maybe I need to know all the routes, have all of them in mind. I don't have to. Do you get what I'm saying? I don't have to. But with the right analysis, are you okay? Anybody can wake up and say, I want to go to Kumasi, but I want to choose the shortest route, which we'll be using Google. Are you okay? But if Google didn't do that, what would we do as a country? I use the same voice as that. Like, what's his name? Chains or something. Double chains. The legend, you know? The legend is, but anyway, we should stop talking about and give solutions. Nobody should laugh at Africa and our situation. So we should find solutions. That's why you are learning this. That's why I'm going to give you a hard question to answer. Because I'm so angry with the situation that I'm translating it. Yeah, the technical people, we know what is required. Okay, it's okay. Let's not get emotional. It's okay. Be okay. All right. Relax. Okay, so some analysis we can do. You'll be shocked. Are you okay? We can do what we call the shortest route. How many of you have used the shortest route? Shortest route. Use it. How does it work? Do you know that the popular name for the algorithm that's the distance algorithm? Now go and look it up and Google it up, and you see the code. Someone sat down and wrote that on a network, if I wanted to get from point A to B, how do I evaluate it and know that this is the shortest route? Are you okay? Now Google also gives you alternate routes. Is that also? So obviously there's a lot that this particular algorithm has to do. Are you okay? How would you do it if you were the one to evaluate the shortest route between 2 points on a network that looks more like this? If you wanted to move from point A to C to F, how do you know the shortest route? Talk to me. Exactly. You need to know the impedance or the cost. So it's not a resistance, this is square resistance. But I know what you're talking about. It's that how much does it cost me to move from what point to point? So for every segment or lane, I need to know how much it takes, how much it costs me. It can even be monetary terms that it will cost you $200 to move. In some countries, not everybody can go to Accra Central. You say, I want to go to Accra Central and buy fish. Okay, sit in a car, like you can afford to go there. Some countries you have to pay a price to be the center. Are you get what I'm saying? So costs. This one, so it doesn't have to be distance, but for now, it's the distance. Okay. What else can be the costs? So this for these lengths. What else can be costs associated with this? So let's assume these are, we don't know the units. So what else? Apart from distance, money, okay, dollar, time. The time. Shortest, which takes the shortest time to get it. Is that also? All right. Right. So let's say how long does it take? Let's know time. Let's out. What else? Now we want a value to associate with a particular road link. Are you okay? So if this were not even a road network and it were a pipe network, we can still. Why do you want to shoot this back first? So it doesn't make sense. All right. So let's take the routes. All right. So accessibility, I don't know. It's a factor you want to add onto it as an impedance, as a cost, accessibility, but you have to break it down. Okay. Slope. Doesn't take the same amount of fuel to travel to Kaswa and back. If you've been driving, you know that it's easier in one direction. If you've really been driving, you will know that it's easier in one direction. As if you are enjoying it, but another that as if you are always kind of fine. If you're checking your petrol level, you are going when you are going back to Accra, it's easier. Yes, I've also seen that. Are you okay? So you see, this is a pipe. Okay, so let's work on this one. How would the algorithm work? So anytime you do it, then you know that this is how what the algorithm is doing. How would they work? It's just checking from initially. You see, an algorithm is a computer, it's a robotic example, mechanistic algorithm. So it will just take 5, 10, 11, which one is the easiest? Right. Initially, that's what it will do. We'll put it down. So you'll select A, B. Then it will take an extra length from these 3 nodes. So add on, we're getting 7, isn't it? So A, B, C, 7, isn't it? Then 8, we selected this one. A, D, which one is the shortest? This one, let's do this one, range, let's do this one. Okay? Just for the example, AD to be getting 10, 30, isn't it? Still large, are you okay? So AD will not be selected, you still have 7. Do you get it? Alright. And then we have what? 13, 11, 13, 11, still large, are you okay? It won't be selected. Alright, but this 11 is the minimum. Going to 8, are you okay? Right. What about this? 8, 11. This 11 again, like it's a non-linear. You're not selecting that. So 11 plus 22 plus 23. All right. Already we having 7 plus. That's a very good. This is a very good example because it's 13. Now remember we had this 13 here. So now we need to evaluate on the final analysis. You realize that if you went this way, you end up having more than that. So it's not a bit. If you go that way, and that's it. No, that's another 13. So this is an alternate way. Right? And if you went that way, 10, 1, 12, 12, 30. So you see, this is what I so just select that way. Okay. So he said a repetitive process of analyzing and evaluating links and their values, and then selecting particular links, deselecting them as you go, and we move from what node to node. All right, and find the branches, go on the branches. So you can imagine that It's not an algorithm I can write on the word. Do you get what I'm saying? You need to visit all the links. It's going to be quite, tedious something. Are you right? But the computer doesn't care. It will do it. Now all the Uber drivers are using probably this algorithm. Meanwhile, there's another algorithm called A star, which is also for shortest path. Are you okay? All right. So that is basically network. Some networks are loops. Okay. And there are other networks which are not. So you can see that they're loops. Some networks are actually, they have direction. Yeah, networks are not even have any direction at all. Are you okay? So we need to take note of that. Let's look at something like, I always use a rail. You know how trains work in Ghana? We don't know how trains work. You brought up in Ghana, probably don't know how it works. We don't use trains. Like I'm saying that there are train, railways, but we talk about rail like I'm coming to this place and I came by train. Are you get what I'm saying? It doesn't happen here. It's all right. So you realize that some, let's say like a one-way street has a direction. So in that case, you can associate direction. Sometimes so it can be looked without direction, and also not looked. There's a region that goes, okay, that doesn't come back to where it's done, right? Etc. etc. Okay, what else can we talk about in networks? We can talk about the traveling salesman's problem. Traveling salesperson. Traveling salesperson. So that the computer does it for you. Is okay. We only talk about it here. So I stood here before I came in here. I was looking out there enjoying the scene. And I saw a man holding a megaphone, all right? And he was just saying that he's a gas cooker repairer, okay? And he's recorded this on one of those systems, and it's playing repeated. The gas cooker man is here, and he's walking very fast. Okay, that's the traveling. It's like that. You don't. So what he's going through? Okay, is how do I visit all my potential clients in such a way that I minimize what? Otherwise, you'll be buying a shoe every 2 weeks. Okay, right. Now that's not really the case. Sometimes a doctor wants to visit his patients. Are you all right? So one question that came in exam was that you are supposed to set up a COVID center, all right? And because a COVID center, medical doctors will be visiting the place. It's all right. All right. So you are supposed to do an analysis, all right, or suggest an analysis that can be done so that doctors can be visiting patients who have been now sent home. Are you all right? Discharged. What kind of analysis would be? Nobody was trying to answer. But that's what it is. It's okay. So you visit clients in such a way that your cost is minimized. Look at Zoom Line, for example, the truck. When they just get into the truck, so talk to your driver, all right? And then find out you're a civil engineer. This is something that you should okay doing. Is that right? How are you able to plan your routes? Or go to Zoom Line, go to the office, and just ask them, are you sure that you're not spending more for your school? And you'll be shocked what you find. Okay? Because depending on the way you go on the network, you'll be spending more. Have you checked the way they move? And the truck doesn't come to your block only. It moves from your block and go to another block. You just don't come to one block and the whole track is. It's a huge track. Okay? Traveling salesman's problem. 10 minutes online, rejoin. Okay, so traveling salesman's problem is one of the network solutions we can get. Is okay. You'll be in the software, all you do is to run it, then you should have a network, then it will compute it for you. Is okay. So we are talking about the theory. Understand the theory. What is going to happen? Why? Because the possibilities are too many. Do you remember factorial in maths? So the possibilities of visiting the different possible routes for that track is like a certain number of factorial. Like so to blow your mind, possibility like so many. Are you okay? Right. We can talk about isochrons. What is cron in English? Cron brings what into your mind? Cron. C-R-O-N. If you're reading the Bible, Chronicles. What's cron? That cron there. What's it about? Oh, but it's got something to do with chronic. When someone is having a chronic, excuse me to say, what do you think is that? What is that? What does it mean? Use a word. I like the word frequent. As a mathematician, frequent means what's the formula for frequency? As a system always down to physics, F equals it relates that when frequency is got to be what? Time. Thank you. Cron is time. So when you convert that Bible, that chapter, that was the chapter in the book, the Bible called Chronicles, into tree, it's just time that they written in tree. Are you okay? All right. So iso means time, same time. Are you okay? Right. So if an isochrone, you put an isochrone around the network. This isochrone is passing through points that you can reach at the same time for certain points. What it means is that if you sit in the car here and you move in 5 minutes, you'll be reaching here. Are you with me? Are you with me? Great. So what are some applications? How would you use this? Just covered this. What would you use it for? Oh, think about arm robbery. Think about arm robbery. Is that okay? Think about arm robbery. Immediately, you find out when did they move? Are you okay? They moved 5 minutes ago or 10 minutes ago. They will be here in this time. You know whether they've gone or they are within. Answer roadblocks. Okay. So these things you are watching on movies, I'm bringing it to you like so this is it. You can do it yourself. Oh really? No, watch this one very well. This looks more like a contour line. So that's very well. So it means that you Google draws something like this for you. Or like what's this like a contour. A contour line. When you walk on the contour line, you never go up or down. Why? Because a line goes to these points of equal height or level. So if you were building something like a rail line, you'd be interested in contours. Why? Because rails hardly go on the slope. You don't have rail line like the train is going up. No. So normally, are you okay? And most cities have been built around rivers and stuff like that. So you can easily get a contour. You can ride on a contour. It saves you cost of fuel. Are you okay? All right. Isochrone does this. It allows you to know one of the applications is that if your customers visited you and you wanted to reward your customers, for example, you could actually use an isochrone. I say that anybody who needs 5 minutes, less than 5 minutes of an isochrone. Yes, okay, or about, but they have come far to visit you. So anybody who should get or should get a. How do you get to know that? By taking their addresses and converting it to coordinates. Is that okay? That's called geocoding. Is that okay? can decode a set of addresses. That's the reason we are doing Ghana GPS with Ghana Post GPS. The main idea is that so that we can apply it, police can use it. People can quickly know where you are if you give out your information. All right. So isochrones can be done. That analysis can be done in the network. Are we okay? Don't let me ask you a question. Don't say you're okay. When you see my question, you will shout to. I'm not scared. No, I'm just saying that you see, ask a question if you don't, because sometimes I don't like when I mark your script and you see someone writing something that's like you wonder, was in the class? Are you with me? So if you feel you don't get it, you just tell me how you understand it. Okay. But I believe this is not the most complicated thing. Are you okay? This is one of the easiest things. All right. It's your ability to express yourself. So when I ask you a question and you can't answer it, and you don't do a good discussion, that's going to be a problem. Is that okay? Make sure you do a good discussion. Is that okay? If you want to talk to me, meet together as friends and discuss these things. Otherwise, if you try to write, especially, are you doing face-to-face exams? Yes. You sit down to answer a question like this. You need to know what you're writing. Then you'll be writing some funny thing, and that will give you 0. The answer can be totally off if you don't understand what you're doing. Are we good? Are we happy? Are you happy? Face to face. And the question is supposed to be analytical questions, critical reasoning questions, evaluation questions. These are the type of questions that we are asking you. So the critical reasoning questions, you see, those questions are what you're going to call difficult questions. Because it will ask you in a way that will make you like, what is he talking about? Then that means the lecturer has set a good question. Okay. And for him, he's being seen as what a good lecturer. Because he set a difficult question for him. It's all right. Okay. Oh no, you'll be fine, you'll be fine, You know experience of hey. Is that what you are doing? Yes. So it's not face to face. No, it's